So you will get the answers, the full worked out memo, etc., etc. Let's go through question 5. And like last time, were there any problems? I see in 5.1, it should have said, write down the equation of the asymptotes. They wanted both, obviously, because it's a hyperbola. Is there anything in question 5 that you would like me to go through? Anything in question 5?
Anything that you guys struggle with, whether it's 5.1, 5.3, just let us know.
It doesn't matter which one. Could we say that we're okay with question 5 then? Let's see what you guys say.
5.6.
Oh, okay, so 5.6. Okay, fair enough. I thought if there was going to be anything, it would probably be the last question. Okay, Beyonce, I hope I've said your name correctly. You're saying 5.3. Okay, so Beyonce, the coordinates at D is the y-intercept. Sure, Siseko. Okay, not a problem. So we'll do 5 and 6 as well. Okay, so D is the y-intercept. So for the y-intercept, you're going to let x be equal to 0. Okay, so your equation, you know that the equation of f, because you would have calculated that already, you know that your equation of f, so let's just put 5.3 over here. So you know your equation of f is going to be 3 over, and here you're going to have x minus 2 plus 3. Did everybody have that?
So we're referring, this is not 5.3, right?
This is not 5.3, no, but I mean, we need the equation. We need the equation to answer the question, all right? So everybody's got that. And now for your y-intercept, you're simply going to make x equal to 0. Okay, so that's why it's out of what? Oh, it's 1 mark. They didn't even give you a mark for making y equal to 0. You're going to stick that in your calculator, and you should get 3 over 2 is your answer. Okay, so that means the coordinates at D would be 0 and 3 over 2. Okay, let's move on. Question 5.5, there was also a question about this. So it is the equation of the straight line which passes through A and the x-intercept. Okay, so you can work out the gradient of that line by subbing into gradient formula, change in y. So 3 minus 0 over 2 minus 1. So that gives us a gradient of 3. So it's the line y equals 3x plus c, and then we can sub in either point. We can either sub in the x-intercept or we can sub in a. It really doesn't matter. Let's say I decide I'm going to sub in a with the coordinates 2 and 3. I'm going to end up with 3 equals 3 times 2 plus c. So I'm going to take 6 away from both sides. So c would be equal to -3. So this is the line y equals 3x minus 3. Okay, that's 5.5. I haven't put the marks on there. I'll do that afterwards. And then question 5.6. This is the one that you guys were asking about. So here, can you see they've told us that g of x is equal to f of -x. So in other words, x has changed sign. So when we write down our equation for g of x, we have to change the sign of x. So that gives us 3 over, and here x is positive, so we're going to make it -x minus 2 plus 3. And then what we do is we factorize out the negative at the bottom. So that would give us x plus 2 plus 3. And a positive value divided by a -1 is going to give us a negative, isn't it? So we've got our positive a at the top, we've got our negative at the bottom. So we can then write this as -3 over x plus 2 plus 3. So it's the same idea. Like if you've got a negative fraction, So you can either write it as -1/5 if a fraction was negative, or you can write it like this, or you can write it like this. The thing is, a negative doesn't belong to both of them at the same time, because then a negative divided by a negative would be a positive. All right, so that's how you would do 5.6. Are we all good with that? If you've got any questions, please do ask. All right, so 1 mark on letting x be 0. Here, 2 marks, a mark for the gradient and that. And here, this was also out of 2 marks. So changing the sign of your x and getting your answer. Okay, Mary Lynn. Okay, because Mary Lynn, you're not making, I understand what you're asking. So over here, this is not going to change sign because you're not changing the sign of y. So if they said this, Mary Lynn, if they said g of x equals negative f of x, then they're changing the sign of y. Then that would end up changing. So in other words, you'd end up with a negative into, and then it would be 3 over x minus 2 plus 3. And then, oh, sorry, I should put a square bracket there as well. And then you would end up changing, that second 3, the vertical shift. You would end up changing it once you remove the bracket. So you'd end up with -3 over x plus 2 minus 3, like that. But it's x that's changed sign, not y. Okay, Mary Lynn? Okay, cool. All right, if there are no other questions about question 5, let's move on and let's go and have a look at question 6. Okay, were there any questions about question 6? I know you obviously need a little bit of time to find your work. Any questions about question 6 that you found difficult that you want me to go through? Pretty much standard questions on the cubic function. In your exam, you won't have question 6. Where it is, it'll be later on after the differentiation, but it's just been grouped together. Yes, it's a cubic function. So it wouldn't actually be here at question 6. It would be later on, but that doesn't matter. 6.4, I'm hearing. Is it possible for me to do the whole question? I can do that if that's what you guys want me to. Okay, so what I'm going to do is a 6.3. So I've got 6.3, 6.4, and then 2 people have said, please do the whole question. Yeah, okay, so everyone's saying everything. Okay, so let's just work through it from start to end. This is a very important question, actually. So I'm glad that you guys are saying work through it, because this is typically what we would expect in this particular section. All right, so I think it is good for us to go through it. All right, so let's get started. In 6.1, they want us to determine the coordinates of A and B. A and B represent the turning points. Okay, so when we calculate the coordinates at the turning points, we've got to use the derivative, because the derivative, the gradient at the turning point, is 0. A lot of people get confused with whether you're calculating the coordinates at the turning point or whether you're calculating the x-intercepts. So for the coordinates at the turning points, the derivative is 0. For the coordinates of the x-intercepts, y is 0. Okay, so make sure you read the question carefully. So the first thing that I want to do here is I want to derive f of x. So that is going to give us, oh, sorry, I'm writing 6 and it's not. 4 times 3 is 12, sorry, x squared plus 54x minus 30. Okay, so I've taken the derivative. My next step is I have to show the value of the gradient at the turning point. So I must show that the derivative is equal to 0. You get a mark for that. So you're going to, in a question like this, you're going to get a mark for the derivative, and you're going to get a mark for letting it be equal to 0. Matrix, like with all quadratics, when you are solving, don't leave off the equal 0. Don't write it in the first line when it's in standard form, and then when you do your factors, you leave it off, or whatever the case is. That happens a lot. Don't be lazy. They're going to penalize you for that. Often in matric, there is an accuracy mark on the line in which your factors are. So if you leave off that equals 0, they penalize you for this. So your choice now is either to do the quadratic formula, or you could factorize. So all of these numbers that are sitting in front of us are divisible by 6. But I tell you what, I'm just going to use the quadratic formula, because then we don't have to worry about having an extra couple of lines of working. So it's going to be negative b plus or minus b squared. Put everything inside brackets. Minus 4 times a times c all over 2a. Like so. And then, of course, you can put that onto your calculator. We are getting a half. Good, iPhone. Maybe we can find out what iPhone's name is, please, Yolanda, so that I don't keep calling this poor person iPhone. Or negative 5. You are quite right, iPhone. We would get a half, or we would get x is equal to negative 5. All right, so the mark that we would have got for the factors, we are getting here for showing that we have subbed in and on both our x's. What we need now are our y's. And in order to calculate y, we've got to go and sub back into our original equation. Okay, so often when we sub in fractions, we get some weird, horrible fraction out. So we're going to sub in 4 times a half cubed plus 27 times a half squared minus 30 times a half minus 1. And then we're going to work out what that is. And then we're going to sub in f of negative 5 as well. Okay, so that would give us 4 into negative 5 cubed plus 27 into negative 5 squared minus 30 into negative 5 minus 1. And then once we've written all of that down, we can then go to our calculators and work out what the answers are. As far as the half going in, did you get, let's see what you guys are saying. Yes, Mary, Somi, sorry. Yes, you have to write the brackets. And you have to make it equal to 0. Okay, so Chelsea, I see you've sent something to me. You say, ma'am, not 4. Did I make a mistake, Chelsea, somewhere? So here you should be getting negative 35 over 4. And when negative 5 went in, you should be getting 324. Are you getting those numbers? Oh, okay. All right. No, that's fine. If I've made a mistake, you mustn't be afraid to tell me. Okay. There we go. Lovely. Okay. So Mary Lynn, you chose to write it as a decimal. Not a problem. Oh, you forgot that you must sub it into the original. Yes, you can't sub it into the derivative. Okay, because remember, your derivative is a parabola. It's not your original function. Okay, so you use the derivative to work out what the x coordinates are, but then you've got to sub back into the original to get the y's. Okay, so let's give them what they want. They wanted the coordinates of a and b, so let's write that down. So at a, x must be negative. So the coordinates there have to be negative 5 and this massive 324. And at b, x has to be positive. So that must be the 1 over 5 and y must be negative. And that's where we get the negative 35 over 4 like such. Okay. All right. So 6 marks. We've got 3 on getting the x. Maybe 1, 2, so that's 4, 5, 6. Okay, so then it must be the marks on the y's. Okay, so that is 6.1, everybody. A very important concept, and I'm sure that that will be tested in your final exams. Okay, so yeah, don't forget at the end to go and write the coordinates. Now in question 6.2, they're asking us to calculate the average gradient of f between points A and B. So the minute they say average gradient, they mean they want you to sub into gradient formula. Okay, because average gradient means you're connecting 2 points on a curve with a straight line. So it's like us connecting A and B with a straight line and then working out the gradient of that line. All right, so subbing in here, we would end up with our change in y. So that would be 324 minus negative 35 over 4. And then in our denominator, we would have negative 5 minus a half, like so. And again, you pop that into your calculator and you should be getting negative 121 over 2. Okay, and we were expecting a negative answer because we know that the function is decreasing between A and B. Okay, so negative 60.5. All right, so 2 marks, 1 mark for subbing in, and another mark on the answer. Okay, let's do 6.3 now. C is the y-intercept of the graph. Determine the equation of the tangent of f at C. All right, so they are giving us a pair of coordinates at the point of tangency, the x at the point of tangency and the y at the point of tangency. How do we work out what the coordinates at C are? And I've specifically moved the diagram into view so that we can have a look at what the coordinates at C are. Can anybody tell me what they'd be? What are the coordinates at C, matrix? How can I tell from the equation of f of x what the coordinates at C are? There we go. Well done, everybody. Okay, yes, Lisedi, yes, Kalipa, yes, Marilyn, yes, Gugu, beautiful. Okay, so the coordinates at C are 0 and negative 1. That's it, Cheslin, quite right. Okay, so this is your x coordinate at the point of tangency. This is your y coordinate at the point of tangency. So in order to get the equation of the tangent, we now need the gradient at the point of tangency. Okay, so we want our gradient at the point of tangency, and we don't have to go and we don't have to write down the equation again and then go and derive it. What I'm going to do is I'm just going to go straight from 6.1 and I'm going to write down what my derivative is. Okay, so I know that my derivative is 12x squared plus 54x minus 30. Okay, so I'm stealing it straight from 6.1. And now I'm going to sub in my 0. Okay, so 12 times 0 squared plus 54 times 0 means that my gradient is going to be equal to negative 30. So now I'm going to go and stick it into or sub it into the equation of a straight line. So this is y equals negative 30 plus c. And I can sub in my point. And in fact, it's going to have, oh man, sorry, I left off the x here, guys, sorry. It's going to have that's the x, yes, it's going to be equal to negative 1, isn't it? Okay, so we've got negative 1 into negative 30 times 0 plus c. So c would be equal to negative 1 as well. All right, so the equation of the tangent at the y-intercept, it's going to be negative 30x minus 1. All right, now what I did here is quite common. just be careful. Don't leave the x off when you are calculating the equation of a straight line. Okay, often when students are writing down their answer, they're in such a rush, they write down the gradient, they leave out the x, and they write down the y-intercept. So be careful of that one as well. That was out of 3. So here it would be subbing 0 into your derivative, getting your gradient, and there is your y-intercept. Okay, last question, question 6.4. They want us to determine the values of x for which the graph is concave up. Okay, so now when it comes to this question, I don't know if you guys remember when we were doing this question in class this year, I had mentioned that there was 2 ways you could answer a question like this. Because they are talking about the values of x for which the graph is concave up, our second derivative is our concavity. So remember, I'm just going to say it again before I get started, y is an output. Okay, so, or f of x, let's use f of x notation. F of x is y, which is an output. F prime x is gradient. And f double prime x doesn't have a symbol like a y or an m that we use, but f prime prime x is concavity. Okay, so the first derivative is gradient, the second derivative is concavity. So understand it like this. When we are talking about our change in gradient, right, we could be talking about, say, something like distance. Okay, speed, as an example of our first derivative, tells us how we are changing our distance with respect to time. When we are accelerating, we are explaining how speed is changing with respect to time. So your second derivative is how the first derivative is changing. So our first derivative is gradient, our second derivative is concavity when it comes to a cubic function. There are other derivatives as well, but we only need to worry about the second one. So now I'm going to talk about the methods, the 2 methods that we can use here. Sorry, I'm just reading what Lasedi said. Man, do you want to sub in the x coordinate into the first derivative to determine the gradient? Yes, you do. Yes, you do. So Lasedi, x is basically like your key in the middle. I often draw it for my matrix like this. So x is the key in the middle. From x, you can get y. Or if you're given you y, you can work backwards to x. And then from x, you have to work to your gradient. So you can't go directly from y to gradient without x. You've got to have the x. Okay. All right, so think about it like that. So x is the centerpiece. Okay, it's like the mom in the home, really, I suppose. Mom's always the central figure in the house that keeps everything together and functioning. So x is the same. Okay, so our 2 methods for calculating the value of x for which f is concave up. So the first method that you can use is midpoint formula, because your point of inflection, which is where your graph changes from being concave up to being concave down, is always halfway between your 2 turning points. So we know our turning points were at -5.5. So I can simply say x is equal to -5 plus 1/2, and then I can divide that by 2. All right, so that would give us a point of inflection at -9/4. All right, or the other way that you can do this is to use the second derivative. It's a little bit longer, I think, but nothing wrong with that. So we're going to do the second derivative. So we're going to derive the first derivative. So again, I'm going to steal the first derivative from there. That's going to give us 24x plus 54. All right, so just like gradient is 0 at the turning points, concavity is 0 at the point of inflection. So that's why I've got to make this equal to 0. And then I can solve for x. All right, so my answer is nearly finished. So now I've found the x coordinate at the point of inflection, but they're asking us to determine the values of x for which the graph is concave up. So this particular function will be concave up. The point of inflection is somewhere over there, and it's going to be concave up after your point of inflection. So that is concave up. So it's got to be bigger than this x value at the pink point. Okay, so your values of x for which the graph is concave up will be those values of x that are greater than -9/4. Okay, so that was out of 3. So if you did it the second way, it would be for the second derivative, making it equal to 0, and then your answer. Or if you did it this way, using midpoint formula, subbing in, I would have to give you 2 marks on that and then another, because the marks, even if you used a different method, it will be the same sort of mark. So if they've given you an accuracy mark on something, they have to give you an accuracy mark on something and something else. Or if they give you a CA mark, then they've got to give you a CA mark in the other method as well. Okay, so that was out of 3. Are there any questions on question 6 before I move on? Anything else you want to ask about this cubic function? All clear. Okay, thanks, Siseko. Thanks, Josh. Thanks, Lesedi. Okay, perfect. Let's move on. All right, now, horrible, puffy financial maths. In my opinion, the worst part of the paper, but that's just me. I don't like financial maths particularly, but there we go. That doesn't have anything to do with you guys. All right. Now, what are the questions with regards to financial maths? And remember, this section is only out of 15. It's only 15 marks out of 150. I'm just sending a DM message. If there's anything here you want me to do, let me know. There you go, Mbali. If you're still stuck, then. Okay, so 7.1.4. Okay, so the question about the sinking fund. Okay, so in 7.1.4, Mark sets up a sinking fund to replace his car in 5 years' time. The bank offers him an interest rate of 7.5% per annum compounded monthly. And then it says, using your answer to question 7.1.3 above, calculate how much money Mark needs to deposit at the end of each month so that he can replace the car in 5 years' time. Not a problem. All right. So that means we need our answer from 7.1.3 in order to be able to do this question. So in 7.1.3, we would have done that by subtracting. Okay, so we would have subtracted the 4,728,1,433 minus the 180,000. Is everybody happy? With that? Does that make sense? You understand where I got those? Because we know what the car is going to cost in 5 years' time, given the inflation rate. So our answer for 7.1.3 actually comes from 7.1.2. And the reason why we are subtracting the 180,000 is because that's what he's going to be able to sell his car for when the time comes. Does that make sense to everyone? Okay, so all right, so here we've got our, let's just write this down. We've got, just give me 1 second, guys. So we've got our 47 2 814,33 minus our 180,000. Sorry, you would write underneath. I'm just going to write next to it because I want to try and save a bit of space. So that gives us 292,814,33. Okay. So a sinking fund is a way of saving money every single month so that you can replace something in the future, right? So when a question involves sinking fund, they want you to use the future value formula. So it's very important in financial maths that you use the correct formula, because if you don't, you're not going to get the right answer. Okay, so we've got to use the future value formula. Our future value formula is F, the future value, is equal to X. And over here, we've got 1 plus I to the power of N in brackets minus 1. And all of that is then over I, isn't it? Okay. So he wants to save 292,814 Rand and 33 cents because that's what he needs to replace his vehicle. When the question says how much money must he save every month, they are implying we need to calculate the value of X because that is our monthly installment. So we're going to put the 292,814,33 on the left because that is our future value. X is what we are trying to calculate. So that means that everything else must be known. All right, so our interest rate, they've told us it's 7.5% per annum compounded monthly. So that's 0,075 over 12. And now he is going to replace the car in 5 years' time. So now we need to know the number of payments that Mark is going to make in those 5 years. So if it's 1 payment per month for 5 years, that would be 60 payments. So this would be equal to 60. Okay, and then here we've got our 0,075 over 12. Okay, so that's what you would be doing in question 7.1.4. And now you need to rearrange and solve for X. Okay, so this part, you're going to cross multiply your F value with your I, and then you're going to divide that value by the brackets. Okay, but all of that can be done on the calculator. Do you want me to show you that on my calculator, or are you happy with me just saying that? Do you know what to do there? You're good. Okay. I see. Did I miss something? Are there people saying you're good? Okay. All right. So you know what to do there. All right. So sinking fund, future value, you're going to substitute in and then solve for X by cross multiplying and then dividing by the square bracket. Okay. All right. Now, question 7.2. Is there anything there that you want me to do? Personally, I would like to do question 7.2.2, but you guys tell me whether you want me to do that. when I had a look at the memo for this paper, I see when it gets sent to you, there's only one method that's shown in 7.2.2, but all good, but we can do it. Let's see, Chelsea. Okay, all right. So there's a bunch of people that are asking. Okay, all right. I personally would be happy to do that because this is the sort of thing that does come up. They are always going to ask you outstanding balance, guys. Definitely, definitely, definitely. So you can expect that question to come up in financial maths. All right, they will definitely ask you a question on outstanding balance. All right, so what I'm going to do, let's just move this guy down. And that gives us a little bit of space underneath here where we can work. Okay, let's get into it. So in 7.2, Mr. Jones is taking out a loan. So that is an important keyword because that tells us which formula we should be working with. And it's a loan of 260,000 and it's going to be paid back over 20 years at an interest rate of 9.2% per annum compounded monthly. Okay, the first question, 7.2.1, is not too bad. They ask us to calculate the value of his monthly payments. All right, so first of all, when you are working with the future value formula, you are going to use it for sinking funds, investments, retirement annuities, pensions. Okay, anything where you are putting money away every single month and it is accumulating or growing over time. That's what future value does. Present value is there's an amount of money in the beginning, a large amount of money in the beginning that becomes smaller over a period of time with consistent payments. So that's going to be a bank loan. It could be an inheritance. It could be winning something from the lottery. Okay, so you've got to use the correct formula. In this case, it's going to be our present value formula that we would need to use. Okay, so our present value formula is present value is equal to X, and then in our brackets, we've got 1 minus 1 plus I to the negative N, and all of that is over I. Now, you could substrate into these formulae. You didn't have to do what I did here where you wrote down future value first. I'm just doing that to give you guys a structure into which I am substituting, okay, rather than just writing the numbers on the board, but you can just substrate in. Okay, you again in maths, you always have to show when you've subbed into a formula. Okay, very, very important. Okay, so he needs to pay off 260,000 Rand. We want to work out his monthly payments, so we're calculating X, 1 minus 1 plus his interest rate. Let's just go up just a tiny bit. It's 9.2%, so this is 0.092 compounded monthly. And it's for a period of 20 years. Now, there's no tricks in this question. We don't have to stress about calculating the value of N. It's not going to change in any way. Sometimes it can do. So it would be one payment a month for 20 years. So that would be 240 payments. So this is going to be to the power of minus 240. And then all over our interest rate of 0.092 over 12. A second thing that I want to mention before I go ahead and actually solve for X, be careful with the interest rates. Okay, so if it's like this, 9.2%, make sure you write 0.092. Okay, so sometimes you're in a rush or you're panicking and you write 0.92. That's very different. That's 92%. It's not going to give you the right answer. And again, to solve for X, cross multiply and then divide by. You're getting an error. Okay, Josh. Now, maybe the reason you're getting an error is the way in which you're entering it into the calculator. So if you want, I can bring my calculator up onto the screen and I can show you. No, it's 240, Cheslin, because it's 20 years. I didn't write 290. It's sorry, that's not a 9, that's a 4. Sorry, it's just badly written, but I didn't write 9, it's a 4. Let me just write it again. It's 240. That's a 4. Okay, so you shouldn't be getting an error on your calculator. When you guys work this out, are you getting an answer of 2372.83? Yes, okay, there you go. All right. So Josh, do you want me to show you on the calculator how to enter that? You shouldn't be getting an error. Yes, okay, all right, Josh. Okay, so everybody just give me 1 second. I just need to call up my calculator and then we're going to do the next question. Okay, and now I need to go back here. Sorry, and I just have to share again so that you guys can see my calculator. All right, there it is. Come calculator, let's move over there. Okay, so Josh, when you are putting this in, this is what you're going to do, okay? You, first of all, you're going to say 260,123, and you're going to multiply that by your denominator, which is 0.092 over 12. Then you can press equals. Now you are going to divide by the bracket. So it's 1 minus, bracket again, 1 plus, fraction button, 0.092 over 12. Now you're going to come out of here, press your bracket, put that in, put in your minus 240. And then you've got to close your bracket again, okay, Josh? Because if you open a bracket, you've got to close it. Right, so it often gives you, well, not often, it will always give you an error message if you don't close that last bracket. And there you go, there's our answer. Okay, you got it now. All right, lovely, cool. So now question 7.2.2, which I'm just going to close this down so that it's not in our way. How much money does he still owe the bank after 12 years? Okay. So there are 2 ways that you can answer a question like this. From the words that are implied, they want us to calculate his outstanding balance at 12 years. So method number 1, okay, which is actually the longer method and it is preferred because you can always use this method in every single situation, is to do this. Okay, your outstanding balance is A minus the future value of your payments. Okay, so, and that is going to be after 12 years of payments. All right, so subbing in here, we would have our A value. Remember, A is P1 plus I to the power of N. Okay, so that's what I'm writing in place of A. It's going to be our P, the value of our loan, 1 plus our interest rate, which is 0.092 over 12. And now we need to know how many payments he's made at this point. Okay, so he would have made 12 years worth of payments every single month. So it's going to be 12 times 20. Sorry. 12 times 12. So, which would be 144. That's it. Minus the future value of his payments. So recall from the previous question, we worked out the value of his payment every single month. All right. We know that it is this value of 2372.83. I'm just going to write that down again, 2372.83. And it minus the future value of his payment. So now subbing into future value, we've got 2372.83. And then here we've got 1 plus our interest rate, 0.092 over 12. He's made 144 payments. Sorry, this is also a 4, not a 9. I don't know why it keeps doing. Just try and write a little bit neater. Minus 1 all over 0,092 over 12. That's it, Siseko. Okay, so you guys can put that into your calculators and you can tell me what you get and I'll tell you what I've got. And then we will discuss briefly why this is the preferred method, and then I will do the second method with you as well. Or I can do it on screen if you like. Or maybe you want just an opportunity to try it quietly by yourselves. Maybe that's better. Okay, so the reason that we're using 144 is because he's made payments for 12 years. So 12 times 12 is 144. Okay, was there another question? Okay, so I've got an answer from Chelsea. What are the rest of you getting? Yes, Lesedi.
Hi, ma'am.
Hi, Lesedi.
Ma'am, may I please confirm something? When we're using
Yes.
this method of getting the outstanding balance, when we sub into the N value, do we sub in the number of payments made or the ones that still need to be made? Because there's a difference in the two.
Yes, there is. So now it depends which formula you use, my girl. Because if you are doing outstanding balance is A minus FV, it's the number of payments that have been made. But if you're using the present value formula, then it's the number of payments that still need to be made. Okay, so in our second method, you're going to see that N value is going to be different. Okay. All right, so the first method is actually the preferred method because you're always going to know how many payments have been made. They could give you a question where you don't know the length of the loan. So if you don't know the length of the loan, you don't know how many payments still need to be made, and then you can't use present value to calculate outstanding balance. Okay. All right, so now for Cheslin, let's have a look. You've got 160. Yes, that's correct. Okay, so your answer is going to be slightly different if you use present value than if you use this method that I've put onto the screen. Now, I see Kalipa and Bali and Chelsea. Kalipa, I don't know if you've pressed something funny, but you are getting a different answer from the rest of us. Okay, so you should be getting an answer of, sorry, just 1 second. You should be getting this, which is what the others have sent through to me, Kalipa. You should be getting 160,825,95. That's what you should be getting. Okay, so just look very carefully at what you've got on your screen. Maybe you've just put in an exponent that's wrong or changed a number or something. I'll just scooch over again so that you can see everything. Okay, now the other way, the second way that you can calculate this, right? This is the formula for the first method. The second one is to use present value. So here, let's just make a little note. Okay, so for this method here, so I'll just put a star there and a star there. N is the number of payments that have been made. Okay, so N, if you're doing outstanding balance, is A minus future value. N is the number of payments that have been made. Here, if we use present value, it's the number of payments that still need to be made. And I hope that makes sense to you if you understand present value. Okay, because it's the present value of his loan at that time and how many payments he's still required to make in order to fully settle the loan. Okay, so here, subbing into present value, we would put in our A value, which is the 2372,83, 1 minus 1 plus I. Our interest rate is 0,092 over 12. And now our N value is the number of payments that are still required. So if you've paid off 12 years of a 20-year loan, you've still got 8 years to go, don't you? So it's 8 times 12. Okay, so there are 96 payments that would still be outstanding at this stage. So over I, so 0,092 over 12. And here your answer is just very, very, very slightly different. There won't be much. It's usually just a few cents. Sometimes it's the same, but often it's just a very little bit different. Okay, so let's just, I've already done this before, but I'm just doing it again. Don't forget to close all the brackets that you open. Otherwise, you're going to get an error message on your calculator. Okay, so doing it this way, you end up with, come on, you silly, Rand 160,824,42. Okay, so just a little bit different. Absolutely, Siseko. Good, Cheslin, correct answer. Yes, Siseko, both methods will be on the memorandum, the marking memorandum. Okay, but I know the first method, like I said to you in the beginning, it's a bit more cumbersome. You will always be able to do the first method. You may not be able to do the second method if you don't know how many payments are still outstanding. Okay, so I'm just going to put a star there for you, and I'm going to say here, N is the number of payments that still need to be made. N is the number of payments that still need to be made. Yes, Gugu, go for it.
Hi, ma'am.
Hi, Gugu.
So I prefer the first option, but I'm still failing to understand why we use the future value method. I don't know what's confusing me, but I'm still trying to understand why we're even using the 144 instead of the 96.
Okay.
It's the future value.
Okay, so in other words, when you are doing your first method, all right, you are working out the value of the loan at a particular point in time. The future value of your payments is how much you have paid off at a particular point in time. Because when you are paying something off, you can also look at it that your payments are accumulating into a lump sum that is now going to be subtracted from what you owe. Does that make sense to you? So it's going
Yes,
to be, so it's going to be the number of payments that you have made at that point. It's going to accumulate. So after so many payments, it's going to accumulate it to a certain particular lump sum, subtract that from the value of the loan at that point in time, and that will tell you what you still owe, what you've still got to pay. With present value, it's like you are doing, it's like you're almost ignoring the first 8 years of payments, and then you are just calculating, again, the present value of the loan at a particular point in time and saying, okay, I want to know from this point onwards, how much do I still need to pay? In which case, it's got to be the number of payments that I'm going to make from that point in time to the end. That's why it's got to be 96. Does that make sense?
Okay, ma'am. Thank you. Thank you.
It's a pleasure. It's a pleasure. Okay, so yes, this is a very important concept in financial maths. They will definitely ask you a question where you have to calculate outstanding balance. All right, so I'm very glad that we went through that and that I was able to discuss both of these methods with you again. If this is something that you want to know a little bit more about, remember, you can go and look on the Watobe website. Earlier this year, Yolanda and I did a whole course on financial maths. We did one last year on Watobe on financial maths. So I would have covered outstanding balance in a lot of detail if you want to go and have a look at some of those old videos. Okay, but yes, definitely something that is going to come up. All right, so your marks here, there's always a mark for subbing into the correct formula. There's going to be a mark in this case on the correct n value and then your answer. So here for formula, correct n and your answer. Okay. All right, so if there's no further questions on question 7, let's go on to, let's just move this out the way again. Let's go on to question 8. Anything in question 8 that you wanted me to do? Any questions from question 8? Okay, so people are asking, okay, so you're all asking about the same things really. Okay, so first principles, I presume you're okay. Remember, when you do it from first principles, do not show that you have subbed in h equals 0. Okay, the other thing is in first principles, they will penalize you if your notation is funny. So make sure that you don't drop your limit notation until you've actually worked out the gradient. And the other thing about first principles is don't let that h in the denominator disappear and then magically find its way back in at the bottom, because they're going to penalize you for that as well. Okay, so you all want 4 out of 4 or 5 out of 5 for the first principles question. Okay, so you're all asking for 8.2 and 8.3. So let's do those together. Let's start with 8.2.1. All right, so this is also a little bit different. Okay, you don't actually have to write your answer with positive exponents. So this shouldn't actually really be here. Okay, they will mark your answers correct with negative exponents. It's not an expectation that you have to write things with positive exponents. So we're actually going to ignore that. This question should have just told us to find the derivative of y with respect to x. Okay, there is never you have to write it with positive exponents. Okay, so when we are deriving using our rules, we first have to prepare our statement, our function statement for differentiation, which means we have to remove brackets, divide lines, and roots if they give us any. Okay, so don't forget about that. So the first thing is that to differentiate, you have to remove brackets, divide lines, and thirdly, any roots, if they give you any. So we need to remove these divide lines over here. Okay, so we would remove the first divide line essentially by writing x cubed over 6 as 1 over 6 x cubed. Then in the second term, which is negative, we've got to take your x squared from the denominator into the numerator. And that means that we have to change the sign of our exponent. Is everybody happy with that? So what you want in the terms on the right-hand side is you want to have the coefficient. Then you want your variable in the numerator with its exponent. That's what you're looking for. Okay, and only now are you ready to differentiate. So you've got to use the correct notation. I'm not writing dy in the first line because I didn't take the derivative. I didn't take a derivative. I simply separated the coefficient from the variable in the first term. And in the second term, I took the variable into the numerator. That's not differentiating. Differentiating is where you are applying the power rule. Okay, so only now am I going to write. Okay, so now I'm ready to differentiate. So now I'm going to write the derivative of y with respect to x, and I'm going to apply my power rule. Be careful of this. Matrics make the same mistakes year on year where they just everything is dy over dx, even when they didn't differentiate. Okay, so they will penalize you for that. Okay, so now we're going to multiply the exponent with the coefficient. So that would give us 1 over 2. And then we are going to subtract 1 from the exponent. Stop. Multiply your exponent with your coefficient. So this is going to be plus 12. And then you're going to take 1 away. So let's just check what you said there, Chelsea. 1/2 x squared plus 12x to the power of -3. I concur. I agree with you. Okay, so in questions like this, they would give you a mark on this first line for taking that x squared into the numerator and writing it with a negative. And then they normally give you marks on the terms. So sign, number, variable, and exponent. Okay, so that's why this particular one is out of 3. Let's look, let's look at the next one. So this is 8.2.2. And here they give us y equals x squared minus 8x plus 12 all over 3x minus 6. No, you don't, Chelsea. No, you don't. Even though it says it here, it shouldn't. It shouldn't say that. They will never say that in the exam, and you do not have to write it with positive exponents. I promise you, I swear. Okay. You will get full marks for writing it with negative exponents. It's not an expectation. It is when you are in grade 9, 10, and 11, but in grade 12 and calculus, it is not an expectation. Okay, so in this case, we have got a binomial denominator. So the only way we can prepare our statement for differentiation is by factorizing. Okay, so we're going to have to factorize the numerator and we're going to have to factorize the denominator. Okay, so I'm not writing dy over dx because I'm not differentiating. I'm still factorizing and getting this function statement ready for differentiation. So I'm going to factorize my numerator. This is going to give me what it would be 6 and 2, both negative. And at the bottom, I'm going to take out 3 and I'm going to have x minus 2 at the bottom. Now I may cancel down something at the top with something at the bottom because I can only cancel factors. I cannot cancel terms. Right, so that is going to leave us with x minus 6 over 3. So again, see here, guys, I'm not writing dy over dx. I'm still working with this until it is in the correct form where I've got the coefficient, the variable, the exponent, and then I'm ready to differentiate. So this is going to give me 1 over 3x minus 2. Is everybody happy with how I got the minus, sorry, the 1 over 3x minus 2? Does that make sense? Cool. All right. And now you're going to differentiate. Okay, so the derivative of y with respect to x, 1 times a third is a third. And then obviously I'm going to take my 0 away and my minus 2 will fall away. So dy over dx, it's actually the gradient of a straight line, which would be 1 over 3. Okay. All right. So Chelsea, you've split it up. So you've got x over 3 minus 6 over 3. X over 3 is 1/3 of x. Minus 6 over 3 is -2. Okay. That's where it comes from. All right. Cool. No problem. Okay, question 8.3 now. They want us to determine the derivative of y with respect to x. And again, like I said up at the beginning over here, we have to remove brackets, divide lines, and roots. Again, you're differentiating and they're giving us this sort of notation. We don't write dy over dx. When we apply the power rule, we drop our dx in our hard bracket, our square bracket, and we just write equals our answer. Okay, and then that's the notation for differentiation. So for now, I'm not differentiating. I'm keeping my notation, just like I kept my y previously. And I'm squaring a binomial. So I'm going to multiply, I'm doing FOIL. So I'm going to end up with 9x squared minus 12x plus 4. Okay, I'm now ready to differentiate because my brackets are gone. And I'm going to drop my dx, I'm going to drop my hard brackets, and I'm applying my power rule. So exponent times coefficient minus 1 from exponent. And then this would be minus 12. All right, and then the plus 4 would be gone. Okay. Is everybody happy with that? Okay, cool beans. We just didn't put in the marks for the second and the third question, so let's just do that quickly. Always a mark for factorizing, a mark on that and a mark on that. And then here, I wouldn't say that this question would be out of 3. I would probably put this out of 2. But anyway, so a mark for removing the brackets and getting that, and then a mark on the answer. That wouldn't be out of 3 at matric level. Okay. All righty. So if we're all good with question 8, we can go on and start talking about question number 9. Now, what I do need to say about this particular paper that has been used for the purposes of bootcamp is that it's got more questions in it than what your exam paper is going to have. All right, so they're not going to give you 2 questions now in question 9 on differentiation. You're not going to get, because this is now your optimization. So there's not going to be a 9.1 and a 9.2. It would be either or, but it's not going to be both. Okay, so there's only one question on optimization. And as you know, it could either be on 2D, it could be on 3D, it could be something on the Cartesian plane, it could be something on distance, speed, velocity, or it could be a question like the one that's been given over here. I'm thinking probably at this stage that question 9 is a particularly, probably the first part, 9.1.1 is quite difficult for you guys. We've only got sort of 20 or so minutes left. what do you want? Do you want, let's just see how you guys feel. Do you want me to do the whole of question 9? Because then I'm not going to be able to do question 10 or question 11. How do you feel? What do you want me to sort of concentrate on now in the last 20 minutes? Whatever is by. Okay, so Cheslin says question 9, please. Bali also says question 9. Okay, so we've got 2 question 9s, 2 question 10s. Chelsea also says question 10. Msomi, I think that that's a good compromise. So Msomi says, what about question 9.1 and question 10? Okay, let's do that. Okay, remember, we will still have an opportunity to speak about things. I can probably in our next boot camp maybe come back and do 9.2 with you. Okay, we are going to talk about common exam errors, but we'll see if we can fit that in. All right, let's fly into this. Okay, so question 9.1.1 is a more difficult sort of question. What they want us to do here is they want us to first of all show that R of C is equal to 2RC over 2. Okay, given that the strength of the reaction strength of the reaction of a person's body to X units of a drug is given by this particular formula, where C is the maximum number of units that can be given. Okay, so in 9.1.1, if R of X is equal to X squared C over 2 minus X over 3, then it means that R of C, so now in place of my X, I'm subbing in my C. I would now end up with C squared into C over 2 minus C over 3. So I am replacing my X with C. Then what I'm going to do is I'm going to remove my brackets. So in other words, I'm going to end up with, and I suppose we could use a lowest common denominator here as well, which would be 6. Okay, so here 2 goes into 6 3 times. So this would give us 3C over here, minus 3 goes into 6 2 times. So this would give us 2C over there. So we're going to end up with C squared multiplied by C over 6, which gives us C cubed over 6. Right. Now, this thing that they gave us, so RC is equal to 2RC over 2. So now what we're going to do is we're going to sub that in as well, okay, into our equation that they gave us. All right, so that means that 2RC over 2 is going to be equal to, because they've multiplied both sides by 2, we've got 2 here. Okay, and now in place of C, I'm going to be putting in C over 2. Okay, so here where I subbed in for C, I'm now subbing in for C over 2. That's what they want to go in. Okay, so this first thing is going to be C over 2, and then it has to be squared. That's this first one with a pink circle around it. Okay, and then inside here, I've got C over 2. Over 2. Sorry, I'm just thinking this one through. C over 2 over 2 minus x is c over 2 over 3. All right, so now this is going to give us 2 into, this would be, sorry guys, so this would be c squared over 4. And over here, if I've got c over 2 divided by 2, that's c over 2 times, that's 2 over 1, so this would be 1 over 2. So this would end up being c over 4 minus. Oh, shame. That's why I said to you guys, I don't know if you actually do want me to do this particular question, because it's really horrible. It's really, really horrible. This is not a nice question at all. And personally, I wouldn't worry about questions like these in my final exam. You don't have to get question 9.1.1 correct. If you, even to do well, you could get 80% for your exam and still not get that right. So all right, so now it's a case of essentially what you're going to do is you're going to multiply all of this stuff out, and you're going to end up with the same answer as we got over here for R of C. That's all they're asking us to do. Okay, all right, so you're just going to end up removing your brackets. I don't know if you want me to continue it, but eventually what's going to end up happening here is it's going to be equal to c cubed over 6. All right, and now that you've shown that they're equal to the same thing, they're going to be equal to each other. That's the idea. Okay. All right, I tell you what, then I'll leave that for now. I know, I'm sorry, this is jumping around a little bit here. Let's go and talk about this, because these are nice questions. I really like these sorts of questions. Let's see how far. Siseko, I'm not 100% sure when they're sending it out, but I think it should be after today. All right, so you'll be able to go back and you'll be able to have a look at this. Maybe what we can do is come back to question 9 at the end of our common exam errors and come and talk about it then. And let me try and finish question 10 now. Okay, but the optimization, unless you are somebody, I don't know if there's anybody here who's getting 80-90% for maths, then you're going to worry about optimization. If you're not getting 80 or 90% for maths, the optimization question is not a big deal. It's generally 10 marks. That's not something you want to stress over. Okay, but you can at least do a little bit of probability. All right, so let's talk about question 10.1, if that's okay. And in this particular question, we've got 5 books. So 3 books by one author, 1 book by another author, and 1 by another author. And he arranges them on a shelf. In how many ways can he do this if there are no restrictions? So there are 5 different things. So that means that there are 5 factorial ways in which they can be arranged. Does that make sense to everybody? So I use factorial notation when things cannot be repeated. Okay, so like if it's people or different books or things like that, things that can be repeated, we would use exponents. Things that can be repeated would be things like numbers or letters. In 10.1.2, they said to us, what is the probability that the 3 books by Grisham are next to one another? Okay, so when they ask us for a question on probability, we have to create a fraction, okay? Our denominator is going to be the number of possible ways in which these books can be arranged. So that's the 120 or the 5 factorial. Now, as far as the numerator is concerned, they've given us a restriction here, and they've said that the books by Grisham have to be next to one another. So Grisham, Grisham, Grisham have got to be together. So we put them together and we group them, we put a circle around them. And then we've got a book by Smith, and then another book by an author called Bryson. These three books by Grisham can be arranged in 3 factorial ways with each other, and then they can be combined with the other books in another 1, 2, 3 factorial ways. Okay, so, and that's where they have that table where it slides down. So you can have the 3 Grisham books together, and S and B, and then next you can have S and then the 3 Grisham books together and then the B at the end. Or you could have the S and the B at the front and the 3 Grisham books at the end. And then the Grisham and, sorry, the S and the B could also be switched around. Okay, but that is the easiest way to work it out. So our numerator here is going to be 3 factorial by 3 factorial. Okay, are there any questions? We're going to work out what that is. Is that okay? Does that make sense to everyone? You guys are quiet. Are you getting 36 out of 120? So I think that is 30%. Okay. All right. So that's important. That's something that your teacher should have done with you in class. Okay. Can I go on to question 10.2? All right. It wouldn't be out of 5. Okay, so Cheslin, that's not correct. Okay, so maybe this could be out of I don't even know if it would be out of 3, because you've got to get your numerator, maybe 3, numerator, denominator, and final answer. Definitely not out of 5. Okay, so I wouldn't put that out of 5, definitely not. Okay, let's do 10.2 and let's see if we can maybe try and finish this in the little bit of time that we've got left. I'd like to do that. So they give us a 4-digit code, not beginning with 0, and they tell us that it is to be constructed from the set of digits 1, 3, 4, 6, 7, 8, and 0, but we can't have 0 at the beginning. Then they ask us how many 4-digit codes can be constructed if repetition of digits is allowed. So the easiest way to do this, this is how I always teach it, is to fill your boxes. So this is a 4-digit code, all right? It can't begin with 0. So now let's go and count how many numbers it could begin with. There are 1, 2, 3, 4, 5, 6 numbers that it could possibly begin with, because we're using these numbers that they've given us, but it's not allowed to be 0. So repetition is allowed. Okay, so that means we can have a 0 now. We can have any one of the numbers that have gone before. So we could have 7 numbers over here. All right, and then repetition is allowed. So we can have 7 numbers over here, and it means we can have 7 numbers over there as well. Does that make sense to everybody? So 6 by 7 by 7 by 7 is 2058. Are we happy with that? Okay, so that would be 2058. Are you guys getting that? Cool beans. Okay. Then in 10.2.2, they've asked us how many 4-digit codes can be constructed if the repetition of digits is not allowed. So again, we are filling 4 blocks. Okay. We're not allowed to start with the 0. right? So remember the numbers that we're allowed to use are, let's just put them over here, 1, 3, 4, 6, 7, 8, and 0. Okay, we are not allowed to start with 0. Okay, so we can't have 0 here. We could have 6 possibilities over there, right? In our second block over here, we can have 0, but we can't have a number if we've already used it over here. So that means that one of these numbers cannot be used. So that means that we have got 6 numbers that we could possibly use in the second place. Does that make sense to everybody? Okay, and then there would be 5 numbers that we could use here, and there would be 4 numbers that we would allow to use over there. So that would be 6 by 6 by 5 by 4. So that would give us 720, which a whole lot of you have been putting in the chat. Well done. Okay, so here it's a mark for your first line and then a mark for your answer. Okay, for both of those. Let's do 10.2.3. Now they've asked us to calculate the probability of randomly constructing a 4-digit code, which is divisible by 5 if the repetition of digits is allowed. Okay, so now, because the question has asked us to calculate probability, again, we've got to have a numerator and we've got to have a denominator, right? So in this case, because the repetition of digits is allowed, our denominator comes from 10.2.1. Okay, so that was the 6 by 7 by 7 by 7. So our denominator in this case is 2058. Now let's have a look at the numerator. They want a 4-digit code which is divisible by 5. All right, so let's go over here and go and have a look. I'm just using it because I want to use these numbers. So now we've got to have a 4-digit code that is divisible by 5. When numbers are divisible by 5, what may they end in? If a number is divisible by 5, it can either end in 5 or 0. So we consider these two situations separately matrix. Good, well done, everybody. So let's consider it ending in 0. Now remember, repetition is allowed, okay? But it has to end in 0. So if it has to end in 0, then there is only one way in which we can fill that last block. Remember, it's not allowed to start with 0, so there are 6 ways in which we can fill our first block. Our second and third blocks can contain 1, 2, 3, 4, 5, 6, 7 numbers. So this would be 7 by 7. Okay, all right, Cheslin, we're going to have a look now. And then to that, we are going to have to also add the probability that it ends in a 5. So we're nearly there. Sorry, Yolanda, we're going a little bit over time here, but I just want to finish this with the matrix. And then
That's
at least,
okay. That's
all
okay.
right, cool. All right, so now it has to end in a 5. So there's one way in which I can fill that block. Again, it can't start with a 0, so there are 6 ways in which I can fill this block over here. I've got 7 numbers in total, so I've got 7 and 7 over there. All right, so these two would need to be added together. In this case, they're actually identical. So I could actually here, I could say 2 by 6 by 7 by 7 by 1, because there are 2 of them. Does that make sense to everybody? So that gives us 2 by 6 by 7 by 7 by 1 over, which gives us a 2 and 7 chance. Okay. All right. Are there any quick questions before we say goodbye? Do we have to do a poll? I didn't know. Oh, 5 isn't in there. Thank you. Sorry, Cheslin, with the going backwards and forwards. You're right. Sorry. You're quite right. So it can't end in a 5. Okay, you're quite right. Sorry, guys. I'm going backwards and forwards. It can only end in a 0. It can't end in a 5. Quite right. So we would actually have to remove that. Sorry, I thought 5 was one of our numbers, but it isn't. Okay, so that would have to come out. Okay, so it would just be, let's just go back here. So it would just be 6 by 7 by 7 by 1 over. Okay, so sorry, 1 and 7 charts. That's what I'm getting. Yeah, there we go. Yeah, sorry guys, there was no 5 in there. Sorry, with me going backwards and forwards, I missed that, but you're quite right. The 5 is not included. Okay, so we don't have to consider it ending with a 5. Normally we would if 5 was there, but there was no 5. So we only have to consider it ending in 0. Okay, so that was actually easier than I thought. Okay, so in Bali, the keywords that you should look out for when it comes to future value, it's a sinking fund, retirement annuity, investment, pension are the keywords when it comes to future value. When it comes to present value, your keywords are loan, inheritance, or lottery, winning the lottery. Okay, Mbali.